Hey guys, it's Jason Snavely, certified wildlife biologist and founder and president of Drop-Tine Wildlife Consulting, the Drop-Tine Seed Company, and of course, Drop-Tine Podcast. Guys, I've 17 years private wildlife consultant, graduated from Mississippi State University.
All right, I need to change that. We're actually over 20 years now. I'm going to cut into that because the podcast I have today is super exciting. I know I say this all the time, but what we're about to present today is going to be mind-blowing. I know if you're driving to work, slow down, take the long way. If you're driving home, slow down. I don't like two-part podcasts. I think you lose momentum. So my guest and I today, we're just talking about some things sort of off the record, and I have so much to go over, but I'm going to just jump right into this. I'm not attempting to sell you on the idea that glyphosate or RoundUp should be outlawed, nor am I here to tell you that it's safe. It's not my position as a private educator. It's my job for clients to seek the truth, continue to educate myself, read the thick literature, and decipher it, and then obviously convey that to my clients. So I'm exposing you to some of the information that I've uncovered surrounding the RoundUp glyphosate story, I guess, if you will. Why does any of this matter? Well, it's simple. If you're still farming with conventional practices, your food plots, much like fast food meals, are full of empty calories and, quite frankly, lacking the nutrient density found where soils are healthy and biologically active, and managers are feeding the microbes. This reminds me of a client's recent comment regarding my wintertime rebuilding of the food plot blends and products for the Drop-Tine Seed Company. Each year I sit down, read customer reviews, client reviews. Obviously, some of you know this. I talk to you, email, text, whatever, and discuss how we can immediately respond to your needs. As you know, I thrive on this work. This particular client made a comment that kind of made me chuckle, and I just let it pass. He said, whatever you do, don't put too many plants in the blend that only fix the soil. Make sure you include plants that deer actually eat. I thought to myself, this exposes, not his fault, my fault, but it exposes the underlying misunderstanding of how this system truly works. The sheer act of putting a lot of minerals in your food plots does not mean that they end up in the plants and ultimately in the deer. Likewise, just because you have green plants and deer eat them doesn't mean that they're gaining maximum nourishment from those plants. I would argue that most food plots, like the American diet, are full of empty calories and void of the nutrition required to produce maximum body weights, maximum reproduction, medicate hundreds of illnesses, defend against thousands of pathogens, maintain gut balance, and obviously ultimately grow giant antlers. So I've mentioned that the chronic wasting disease story is colossal. I have enough research to produce a book with so much mind-blowing information on the history and the hidden facts surrounding CWD, but truthfully, more than half of my natural resource colleagues would stop talking to me. So I'll save that for another time. What you read about in the popular literature is an attempt to please the ignorant masses like you and I, who are customers of state agencies. The fact is, the white-tailed deer is the most popular game animal, and it represents a significant percentage of the revenue streams of state agencies. No white-tailed deer equals no licensed buyers, no state-funded pensions, no fancy office in the state capitol, and certainly no reckless spending of taxpayer dollars. In other words, they'd have to be fiscally responsible like small business owners and entrepreneurs. In so many ways, the CWD story is strikingly similar to the glyphosate RoundUp story that my guest and I are going to talk about today, and I think he'll agree with me there. Except if you follow the money to the likes of Monsanto, Bayer, Syngenta, BASF, you name it, and I'm not particularly against these multinationals, they're free to do what they want to do, you will find an even bigger industry that has billions of reasons to defend itself. The regulatory capture, flawed science, and both elected and self-proclaimed experts who have never conducted any of their own CWD research, like Kristen Schuler of Cornell, or so many at nonprofit organizations who've never actually studied live or dead cervids in their lives, but are called upon to educate you and I about CWD. I watch as my friends, family members, and peers absorb this information, and it, to be honest, irritates me. After spending hours upon hours reading the CWD and associated TSE research, speaking to the real experts, of which a couple have been on this podcast, many off-the-record conversations with friends willing to share their experiences within state and federal organizations, and then musings over my own findings and those observations I've made over the last 21 years, I'm convinced that we know a lot more about the causes of CWD than they want us to believe. After all, the funding slows down to a trickle, or worse, if the puzzle is solved. Sometimes science is totally ignored, brushed under the carpet, because it doesn't speak to the narrative of those in charge of governments or lawmakers or politicians, or anytime big money is involved. Corrupt government officials and lawmakers from both sides of the aisle are oftentimes great at getting in bed with academics at land-grant institutions in an attempt to subvert science. Oftentimes, they are highly, well, I'll skip that part, as we'll cover much of that today. But instead, our ignorance is a complex topic and often brushed aside. But before you accuse me of being a science denier or a conspiracy theorist, consider the recent but certainly not isolated case where a research contract gave Bayer, who's the current owner of RoundUp, and Syngenta control and the ability to influence the design, conduct, and interpretation of a neonicotinoid study, then gave full unbiased credit to an Iowa State University researcher in the Department of Entomology. Whether you agree that neonics are toxic to bees or other beneficial pollinators or not is besides the point. When the funders who bring the money to the table get to set the rules and interpret the investigative results, we're no longer dealing with independent university research. During my extensive research on CWD, several studies landed on my desk that discussed many of the direct and indirect consequences of using such a powerful, broad-spectrum mineral chelator and antibiotic, i.e. glyphosate, sprayed as a herbicide and a desiccant. I believe there are several strong correlations between the TSE family of prion diseases and the overuse of synthetic chemicals such as glyphosate. The research is there to back it up. Why haven't we been exposed to it? In a few minutes, I'll talk to the leading researcher on this topic, but first, I want to put all this discussion about synthetic herbicides into context. In 2015 and 16, I was a decade and a half into consulting for private and corporate landowners all across the country. As a certified wildlife biologist and a student of whitetails, constantly learning from my clients, from just being in the field, and from the whitetails themselves, I kept busy helping clients develop early successional habitats, prescribe doe harvests, conduct trail cam surveys, manage buck harvest to attain maximum antler size at maturity. The list goes on and on. Summarize observation and harvest data to report population demographics, including estimated densities, adult sex ratios, buck age structure, and of course, fawn recruitment rates. I gave my input on how and where to hunt specific properties, right down to specific targeted bucks, even though I'm not a professional hunter tracker from Africa, and I spent a lot of time developing properties for overall hunting satisfaction, including a few of my own. These are just a few of the services I offered, and I still offer my consulting clients to this day. However, as many of my competitors and colleagues were following the conventional practices of farming and displaying those practices on web shows and YouTube to satisfy their sponsors and advertisers, I observed fields that were experiencing dysbiosis just as I was experiencing with my own health around 2009, 2010. If it weren't for a couple dream hunts and the training required, I might have never realized how to nourish and restore my own body. After a sheep hunt in the Northwest Territories in August of 2015, I returned to a drought and failed food plots. It dawned on me that my soils were experiencing the same mistreatment as my own gut just 5 years earlier. That day, I began to look at the soils as a living organism. After experiencing several stomach pains and diarrhea while working with chemicals on multiple occasions, I ditched all of my synthetic herbicides and insecticides, winterized my sprayers, and learned how to farm without them. This may or may not be the right answer for you, and I still have those chemicals sitting on the shelf in my barn, although my sprayers still have the same pink RV antifreeze in them. I started my podcast so that others could enjoy and join in on the conversations, or just a few of the conversations that I have with some incredibly accomplished people, thought leaders and generous professionals like Fred Provenza, Gabe Brown, Dr. Bruce Leopold, and Dr. Steve Damaris. The conversation I'm about to have today with Dr. Don Huber is one of those conversations. Don is a retired U.S. Army colonel, retired professor of plant pathology, and a true expert on soil-borne diseases, ag bioterrorism, microbial ecology, nutrient disease interactions, and biological control. More than anything, when you search his name online, you find someone who the GMO and glyphosate or RoundUp camp wants to hush, or, as I'm sure Don will describe, perhaps worse. I enjoy people like Don, and I think you will too. In fact, if you can find several of his hit pieces on Don on the interweb, these hit pieces from people like Dr. Kevin Folta, who I before this podcast, off the record, gave Don the opportunity to say he didn't want to talk about this, and he said, let's talk about it. Academicians, physicians, tough guy farmers, and soccer moms selling chemical herbicides who want to discredit Don's storied career are abound. This is one of the reasons I wanted to talk to Don. In his defense, I'll point out that some research I did on one of his most famous critics and detractors, who I just mentioned, revealed that a New York Times article uncovered that particular critic of Don was in bed with multinational agribusinesses, including the makers of RoundUp, who sent him on a trip to Hawaii in the name of education. Don knows his craft and stays in his lane. He's a thought leader, a pioneer, a veteran of the country I love, and he demands to be heard. Finally, before I hand it over to Don, I want to give you a timeline on glyphosate and RoundUp to put all this into perspective so you understand that it didn't just hit the scenes in 1996. Glyphosate was actually first patented in 1964 by the Stauffer Chemical Company to clean pipes and boilers for its ability to grab or chelate, a word we'll use a lot today, I imagine, the calcium, magnesium, and iron in the boiler and descale it. In other words, it's a broad-spectrum mineral chelator. In 1974, glyphosate was patented by Monsanto as a broad-spectrum herbicide, which meant it essentially killed everything. In 1975, Don began researching this new agricultural herbicide, and that's why I think Don is one of the greatest guys to talk to on this topic. He's been there for the whole journey. In 1996, the year I graduated high school, Roundup Ready technology and genetically engineered crops hit the scene. 2000 and 2005, glyphosate was patented by Monsanto as a broad-spectrum antibiotic that ironically harms our beneficial organisms in our GI tract while stimulating the pathogens or the bad things, perhaps setting the stage for a pharmaceutical company to purchase the product later down the road, as did happen when Bayer absorbed the company and its massive number of case settlements. Now, I know that was long, but I wanted to get all those points out before I introduce Dr. Don Huber. Don?
Well, Jason, I think you've probably covered all of it.
No, sir. I don't believe so. This, as I said to you earlier this morning, this topic it's huge. And I'm thankful that you're willing to sit down with me because I'm just not a typical questioner. I need to know the fine details, and I have a lot to cover. So I know my listeners don't always tune in to listen to me. Is there anything that I misspoke about or that I got wrong on your bio?
No, it's fairly complete. And I got interested in glyphosate because we were seeing some changes in plant diseases and conditions that shouldn't have occurred if it is a chemical that only affects the shikimate pathway by shutting down the EPSPS enzyme. Then we shouldn't have seen all of these other abnormal conditions starting to show up. One of those conditions was an increase in disease severity for a specific disease that I had spent much of my career up to that time trying to understand and to move forward. It's one of the most intensely studied diseases that we have, and that's the take-all disease of cereals, a root, crown, and foot rot pathogen, fungal pathogen. And in my years of research on that disease, we had identified one common characteristic that predisposed to the severe root rot, and that was the deficiency of manganese, an essential nutrient involved in photosynthesis and also disease defense by the plant. Certainly, things that we were seeing after glyphosate had been applied in experimental plots, and also then after it became commercialized in 1974 on a much broader scale, didn't seem to fit the story that we were being told, that it was much more intense than just shutting down the EPSPS enzyme at the start of the shikimate pathway. So that just from a curiosity standpoint, to see if we had missed something in our 20-year systematic study of the disease, looking for common denominators, I started out with what's become a long-term interest in the role of glyphosate and similar types of compounds that fit in this overall picture of nutrient disease interactions. So, as you mentioned, it's a very broad spectrum chelator to immobilize essential nutrients. So we know now that there are about 291 plus enzymes that it interacts with as to inhibit activity. There are about 30 that it will stimulate. So that this type of activity is rather phenomenal to have the impact that we see. And the review of glyphosate as a chemical some years ago. It was mentioned that it'll probably be 100 years before a chemical with as broad spectrum activity and characteristics as we see with this synthetic amino acid that we call glyphosate, before another chemical of that type will be invented or discovered. So it is truly phenomenal in its broad spectrum of activity, including not just the chelating, but the antibiotic activity that we see with it also.
Right, and we'll get to that here. And I want to back up real quick and just sort of cover this, the misinformation that is often given and accepted, I guess, out there in general. I was at an event, softball. My daughter was pitching in the state championship, and there was a mother who sold chemicals. Her husband's a farmer, sort of, and there was another mother who was just, honestly and genuinely talking about her preference for organic foods and how important she felt it was to eliminate chemicals from her children's diet and what have you. And adults were drinking, not a lot. I wasn't there. I just heard the story, but it's always sold as glyphosate or Roundup only negatively impacts plants. Now let's talk about the system. When you say systemic activity or movement throughout the plant. So I know, obviously, phloem and xylem as a biology major. This is a phloem mobile, right? It's a two-way transportation. So the xylem moves water and dissolved minerals up through the plant. But the phloem carries glucose, amino acids, etc., throughout the plant, up and down. And it's a major, like a highway, transport system. So, in other words, just a drop, am I correct, of glyphosate or Roundup on a plant will distribute itself throughout the plant. You don't necessarily have to have full coverage. But that when we say systemic activity or movement throughout the plant, that's what we're talking about, that mode of operation or the way it kills it.
Well, that's one of the things that makes it such a great herbicide, is that you don't have to have that complete coverage so that your volume of material can be reduced dramatically. And it's also indicated by, on the labels, they will label it as glyphosate gets the roots.
Yeah, kills the roots.
And that's because it's systemic.
Right.
It moves through the plant. It moves through the body, but it accumulates in certain tissues to a higher degree than in others, and that's in plants. That's your growth tissues, your meristematic tissues, so that your apical meristems, your shoots, and those materials are sinks for glyphosate, or places where it accumulates, and also the reproductive structures, your seed and those tissues. And you see the same thing in humans and animals, that it accumulates in the brain and the heart and the reproductive tissues, or where you find the higher concentrations. Even though it goes into all tissues, it's accumulates in certain ones to a greater degree than in others.
Perfect. And we'll talk about that more as well. But I want to go into the fact that at this event, I hadn't heard this exchange of words, and the gal selling the chemicals for her daytime job made the comment that she said you could actually replace the cocktail or beer, whatever this other lady was drinking, with glyphosate and drink it, and it's safer than the alcohol you're drinking. I would have loved to be a part of this conversation, by the way. I would have brought up the shikimate pathway and asked her if that's what she was referring to, but I think that our listeners should understand that glyphosate's claim, or, Bayer, but the glyphosate claim is that the mechanism of action in plants is that it, as you said, it shuts down or affects the EPSPS enzyme, which is the start of the shikimate pathway. So what they're saying is mammals do not have the shikimate pathway, and as a result, glyphosate does not affect us, human beings, etc. And I think this is a very simple misunderstanding, and the common layman doesn't go any further than this. Am I correct on that when we talk about that pathway?
Well, that's correct. However, if you look at other places in that pathway where minerals, where iron and boron and manganese and other elements are involved that glyphosate interacts with, you'll find that all throughout that shikimate pathway, which is responsible for the hormones as well as the defense mechanisms of the plant, that any of those parts where you have a mineral, cation type of a mineral that is chelated by glyphosate, are also inhibited. So it's not just the EPSPS enzyme. In fact, Monsanto sued another chemical company for patent infringement. And in the lawsuit, the other company said, well, you don't have a valid patent because you patented the EPSPS interaction, but it's actually the 7-acetohepulose phosphate enzyme that precedes the EPSPS in the pathway. Therefore, it would be the chelation by glyphosate of cobalt by glyphosate, because cobalt is the cofactor for that other enzyme that precedes it. It's been reported that the lawsuit then went into a confidential forum, and both parties came out and announced that they had settled it out of court, because if that would have been pursued and the cobalt chelation would have preceded the EPSPS, it may have avoided about 1,100 lawsuits that had been already won by on the basis of the EPSPS enzyme. So
Okay.
there are many other.
I think the interesting thing about this is that the claim that Gly does not harm humans, mammals, because the shikimate pathway is absent in those critters and us. But I think it's key and instrumental to point out that the shikimate pathway is present in our beneficial gut bacteria, or we're talking bacteria, archaea, fungi, algae, some protozoans, I believe, and plants. So to make that statement that it is absent in animals or humans is ignorant of the gut biota, basically, and how we are as human beings. And I do want to say that there's going to be a lot of times in this podcast where we kind of relate it back to human health, but when we start talking about gut bacteria, it's important to understand that in ruminants, when you create a dysbiosis or you interrupt that balance of gut bacteria, you throw the entire system out of whack. Would you agree with that?
Yes, in fact, that's why where you see the direct tie between, excuse me, a direct tie between 12 of our diseases with glyphosate is because of that dysbiosis from its antibiotic activity against the beneficial organisms. So that you see everything from autism, Parkinson's disease, and the whole works that are all involved and all predisposed to by glyphosate.
Crohn's disease, inflammatory bowel disease, Alzheimer's, depression. Yeah. And I guess this is where I'll just drop this bomb. Chronic wasting disease, as I mentioned in my intro. So this is one of my major points. And I guess I'm jumping to page 8 when we should be on page 2, but that was a great segue to this. As I've been researching CWD, how is glyphosate or Roundup, which the two aren't technically interchangeable, I think maybe we'll talk about that, impacting the microbiome of the gut of white-tailed deer? So in other words, you have both the beneficials that have jobs to do, and then the pathogens that are either resistant or, as you and others have made the comment, there's some papers here that prove that some of these pathogens, the bad bugs, if you will, are actually resistant or quite honestly benefit from the glyphosate. When I was doing the CWD research, I was not expecting to land on so much glyphosate research. I think it was Minich and company in June of 2021 published a paper looking at the differences in gut microbiota. I believe I sent it to you. I'm sure you saw it. In white-tailed deer between a couple game farms, and then they looked at free-ranging whitetails, and they looked at the different sexes, and then they looked at CWD status. So positive CWD whitetails, and they looked at their basically their gut bacteria and compared that to those who were non-detect or didn't currently show CWD. And I found that to be completely interesting, because if you completely disrupt the gut bacteria populations and major functional groups, that critter can't operate as it was designed.
Yeah, you'll see that that's a direct relationship of mineral nutrition. It would have been really nice if, where they already had the data on interactions of point of origin of their feed, of their sex, and chronic wasting disease involved there with that change in the microflora. Mm-hmm. Would have been nice if they would have pulled that out to those that were exposed to glyphosate and those that weren't. In that situation, you would find a very dramatic difference that would be so closely related to the glyphosate exposure, I think, that it would give a direct cause-effect relationship. They didn't do that, but that's a follow-up study that would be very interesting and very informative to follow relative to Purser and the other research that they've done, where you see that with chronic wasting disease, you always see that relationship to manganese and copper and the displacement in that with all of the prion-type diseases. And we see that same thing in plants. Mm-hmm.
Yeah. So as far as that chelation, again, chelation or the chelating effect on these minerals means it's grabbing those minerals in the soil, disallowing them to be utilized by the plant. So you can dump as much fertilizer in the ground as you want. The Roundup is not allowing those minerals to be absorbed. And I think I read somewhere, correct me if I'm wrong, but 60% of our proteins rely on copper. And when you have glyphosate chelating copper at a higher rate than manganese, this was sort of that CW. This is I'm not kidding you. I sat back in my chair at my desk and I kind of chuckled, but then my eyebrows raised. And I thought, wow, you don't hear any of this from any of these fantastic CWD researchers or nonprofits. But when glychelates copper at a higher rate than manganese replaces copper as that transitional element for those proteins, and the result was misfolding of the proteins. And I'm thinking, here I am, a student of wildlife biology. I was always told that, the disease-associated prion protein in CWD is some, sci-fi misfolding of the protein that nobody knows how or why it gets folded. And I'm thinking, how come no one ever at least threw this on the table and said, hey, some of the chelators, broad spectrum chelators, which ironically, I mentioned this to you in an email. If you listen to my timeline and you listen to the CWD podcast, you hear quite a few overlaps in that timeline. But I guess the question is there. Well, it's not a question. There is a link between excess manganese and prion diseases, and I think you know quite a bit about the Creutzfeldt-Jakob disease, CJD. Possibly a major epidemic. A lot of you remember the mad cow disease and the fears over that. So in low copper areas, high manganese areas, how come we're not researching the incidence of CWD where gly is used and where these conditions are present?
Well, you'll see it present where you see high incidence of glyphosate usage. Now, it's used so universally that gets kind of gray areas that come in there, but early on it was very clear what those, how that tied in directly with the mineral nutrition. In nature, you'll find those areas where you have an imbalance in nutrients, where you have a very low copper naturally and a very high manganese. And you'll see that relationship with glyphosate, because of the chelation stability constant is almost 1,000 times greater for copper than it is for manganese. So it's going to remove the copper that's essential for brain function and that's then replaced by the manganese, as you indicate. Copper has the 2 valence points. You've got 6 potential with manganese, which then brings about that protein folding and its autonomous ability to replicate and to keep growing. Even though it's not a living entity, the environment is such that it's able to maintain itself and continue to reproduce.
So I think the point to drive the CWD, I really wanted to cover the CWD thing because I think it's important. And hopefully some of my science buddies in the academic world hear this and maybe run with this. I'm just sort of throwing this out there. I won't, because I'm going to go to Indiana next and try to figure out how we can shoot bigger bucks on this particular property. But glyphosate is a synthetic amino acid, right? And it replaces glycine that ultimately causes, correct me if I'm wrong, but my understanding is that's what causes this misfolding. Was it Samsel, I believe, for my science buddies who need the citations? Samsel said that basically when this happens, in other words, it replaces glycine in our own protein, it causes that folding of the proteins. That's very much similar in the TSEs, the transmissible spongiform encephalopathies, such as CWD, Kuru, mad cow, CG, whatever, blah, blah, blah.
It doesn't have to replace the glycine in the protein to cause the folding, because it's the metal part of the metalloprotein that is associated with the function there. So it's a functional relationship that brings about the folding, even without having to be incorporated directly into the protein itself. So it's an external entity that comes into play, has a very close relationship, but it's not actually a replacement of the glycine that's required for folding of that protein. It's the valence change difference that's involved there.
Okay, so this kind of research would probably be relatively difficult to conduct at many universities where the makers of glyphosate donate so much money and this includes land-grant universities. But sometimes you have to look at this and wonder why we're not doing more research on this. But anyway, so let's jump into the chelation a little bit more and sort of put that to bed, because I think that's tied to food plot fertility. I know I explained to you that we call them food plots. Most of the properties I work with, I think we're at that agricultural level. It's not just a throw and grow or some shiny bag. We're working pretty hard on the fertility and nutritional quality and nutrient density. But I want people to understand as a take home, because there's a lot of information here, that glyphosate, it's not, a lot of people think about, oh, it touched my skin, it's going to cause cancer, and we'll get to that aspect, but I want you to understand that it's a very broad spectrum mineral chelator for the cations, iron, aluminum, copper, nickel, manganese, magnesium, zinc, whatever, and it basically grabs these essential minerals, immobilizes them so that they're not functional, making them unavailable for plant uptake and unavailable for, obviously, your deer and humans that eat them. So, I think I heard you say somewhere, or put this note on my desk. It says a pinch, or 1/40th of the recommended rate, will reduce the uptake of manganese and zinc 80 to 90%. Is that true?
Yes. You'll find that in Chakmak's research and Volkaram Hell's, a number of those people who have shown that even from a drift standpoint, it's a very powerful chelator. Do a lot of consulting in Central America and South America. One of the projects we have is on trying to eliminate glyphosate as a desiccant for sugarcane. Mm-hmm. You say, and the reason there is that 1/4 of the sugarcane workers, these are your 17 to 25-year-old young men usually, but 1/4 of them will die from end-stage kidney failure because of glyphosate exposure. You see the same thing in Jasmanian's research in Sri Lanka with the hand harvesting of rice, where they've used glyphosate as a desiccant. Well, it goes out as a desiccant to shut down the metabolism of the plant about a month before harvest. So that in sugarcane, we're actually using it for birth control to stop tiller growth, so that all of that energy can go into the storage for sugar in the stalk rather than producing a bigger factory with those tillers. But you say, well, if it goes out a month before harvest, how do they get exposed to the glyphosate? And the other factor that's involved there, they burn the sugar cane to get rid of all of those old leaves and the trash and that before they harvest, so that they don't have to handle as much material in the mill, and the workers certainly aren't exposed to it as much. But if you watch them, you'll see that they'll chop off a little 6-inch or 10-inch chunk of the stalk and put it in their mouth to chew for the sugar and to give them some energy, but also just to do something while you're physically involved.
Oops.
And even though it's a month after it was applied, it concentrates and is stored in that stalk with the sugar. It's not degraded and decomposed. It's gone through a burning process of the trash, but the sugar's still there with the glyphosate, so that that's where they get it. It mixes with the minerals then in Sri Lanka. Jasmani and his group showed that it chelates the minerals. Then in the body, that they have the high mineral content in their water, drinking water, chelates, and it plugs up the kidneys because it can't pass the glyphosate chelated minerals through the kidneys then, and the end product is a fatality from end-stage kidney failure. And so we've been developing alternatives to that, have a very effective one, where we merely replace the glyphosate with a mineral solution of boron and manganese and molybdenum. These are all essential minerals to use the excess nitrogen and those other materials and produce more sugar with it rather than just killing the plant off to stop new tiller growth. And but you'll see that relationship to the chelation and the end-stage kidney failure is a very direct one, very well-established mechanism from a chelation standpoint.
So before I get to my punch there on the nutrient density in forages, I want to jump back since you've said it several times. This word desiccant, it's a dry down material. So they've approved the use of gly as a desiccant, and they use that to ripen wheat a lot. Am I right? I think they applied it at the hard dose stage of wheat, maybe with some ammonium sulfate, and then that quickly and evenly ripens the standing crop. Am I right about that?
Yeah, you'll see it for your cereal crops in the northern tier of states, and especially in Canada. It's used to dry down for harvest your pulse crops, your beans and lentils and flax. Quaker Oats announced this year that they wouldn't be purchasing oats, for instance, that had been desiccated because of the high glyphosate concentration that's been found in the oat products especially, but it's also in any of them that are desiccated. Tony Mitra published an ebook on Amazon 3 or 4 years ago titled Poison Foods of North America, just reporting the high concentration of glyphosate in a 250,000 analyses that the Canadian Food Inspection Authority had run. So a very serious point of contamination from our own health standpoint.
So I chuckled when you mentioned Quaker Oats because I have the label from I love oatmeal. I had oatmeal this morning and put some granola on top of it. Just happens to be Quaker Oats, my oatmeal this morning. A lot of times I have cream of wheat and grits too, and I was going to ask you about that. So kind of ironic.
Yeah.
Now, going to the desiccant aspect of it, I have CWD wrote here on my notepad again. Is it safe to assume that if they're spraying this at that point to ripen the wheat, that the glyphosate is obviously being consumed from the grain by any white-tailed deer or any critter that walks out there to eat it at that point?
Yes. In fact, what you'll see is Judy Hoy reported this last spring that you still had entire herds of deer now in the Pacific Northwest and on over into Montana and those areas, that the entire herd was still running with the buck because none of them were pregnant in the fall. And you'll see that effect of glyphosate on sperm quality, sperm drop, and reproductive failure. But after harvest, with this systemic chemical, it's in the straw and the residue that those animals are grazing on throughout the winter. And there are very high concentrations that are there. Ted Dupemeyer, a veterinarian in Saskatchewan, one of the authors in that Africa book that from the symposium there in Africa that was held, and he shows that liver damage, kidney damage, all of those have a direct relationship to glyphosate concentration that's in those tissues.
Yeah, and you mentioned Judy Hoy. She back in 2002 did that, I guess, landmark paper on the genital abnormalities in whitetails in west central Montana because of pesticide exposure, or at least as a possible cause, as was in her title. So I want to bounce back real quick before I let this go, because it's been a topic of conversation on this podcast and with clients when I'm working on their nutritional programs and their food plots. But so we're talking about the chelation, and you mentioned the manganese issue, and obviously all these other significant nutrients. Is it safe to deduce and assume then that glyphosate reduces nutrient uptake, having a negative cascading effect on nutrient density in food plot forages if it's been used or is being used? I believe in this. I've read enough research to suggest this. Very difficult, obviously, to research this and prove this. I think we'll have more in the future. David Montgomery's paper was sort of a monkey's paw in this subject, and I think there's more to come on that. But when folks say to me, you're making an assumption that there's no scientific evidence to back up this whole nutrient density claim.
No, that's not true. You have a series of papers out showing the difference between glyphosate and non-glyphosate treated plants and the reduced nutrient density of those crops. You also see it especially with the GMOs for glyphosate tolerance. You'll see 16 to 23% reduction in almost all of your cations. There's a difference in chelating stability constants that you see, but there's a project going on now, a group of scientists in the Midwest that are researching soggy sauerkraut, or sauerkraut that isn't as crisp. Started looking at that, and well, that's generally for onions and cabbage and a number of plants. When you're short on copper, that's one of the essential elements, along with manganese and iron, and that, and the shikimate pathway, which is how you get your secondary cell wall formed for that crispness. That if it's deficient in copper and manganese, that you're going to have soggy sauerkraut, or you're going to have soft onions and that on it. Well, in this particular study, what the scientists found was that, yes, that's true, that the sauerkraut has much lower concentration of copper and manganese, so that they looked at the grower's program, and it was a very excellent program. Had a full nutrient supply, using a lot of organic sources of his nutrients, the animal manures and that. And it should have, the cabbage coming off of that should have been very high in all of those nutrients, and yet it was very deficient in two of them. And those two were critical for that secondary cell wall formation through the shikimate pathway. Then they went back and looked at the glyphosate concentration of the manures and found that you had a high enough level of glyphosate in the manure to completely chelate all of those minerals, so that you had very limited activity or uptake of the minerals by the plant. And consequently, you didn't get the secondary cell wall formed, even though the minerals were applied, they were chelated by the glyphosate, not available for that physiologic function in the plant.
And I saw a I think it was one of your slides. So I can already think of 2 or 3 companies that are asking me for this data when I comment on this. I'll have to defer to you, but you showed a slide with the percent reduced nutrient density in Roundup Ready versus non-Roundup Ready alfalfa and soybeans. And then you had a whole list: NPK, calcium, magnesium, sulfur, boron, copper, iron, manganese, and zinc. And a few caught my attention in soybeans, especially because everybody tells me, no, I want to plant soybeans. That's what kills big deer, grows big deer. 40% reduction in the Roundup Ready versus the non-Roundup Ready in nutrient density when looking at nitrogen. 26% in calcium, 30% reduction in magnesium, and this one here, manganese, 48% reduction, zinc, 30% reduction. If you think you're getting a cold or you feel like you're coming down with something, or you were, afraid of the COVID-19 pandemic, the zinc, if you hammered zinc, I find, and others who do this, it either lessens the symptoms, or if you're proactive on it, almost completely eliminates illnesses. And I fly a lot and shake hands and do that kind of stuff. So a lot of times I feel stuff coming on, especially after a plane ride. If I'm taking my zinc, my immune system seems to be cranking.
You also want that zinc with a good chelator like quercetin or hydroxychloroquine, or so that zinc can get to the target area. In that case, the chelation is a positive because it increases solubility. But with glyphosate, it immobilizes it so that it's not soluble and not taken up.
Good stuff. Okay. Moving on. I want to talk about desorption and remobilization. So, in other words, you've talked about chelation and the fact that glyphosate grabs a hold of these minerals and basically prohibits the plant from using them. At what point, and is there anything, a nutrient or mineral or whatever, that forces that bond to shatter, essentially remobilizing that glyphosate? And if it is, does the glyphosate still act like glyphosate when you first applied it?
Yes, when
did that make sense?
Glyphosate is detoxified fairly quickly. You used to see the ads and it'd say poof and it's gone. It's sprayed on. If you have a till soil and a lot of clay exposure particles and whatnot, it will be detoxified fairly quickly. Or on the label it says don't add anything with this as a tank mix. Don't add your minerals. In fact, at one point in time, I thought that if Monsanto and suggested this to them, that if they would find a chelation that would maintain the availability of the mineral rather than tying it up, and use that as a tank mix, that it would be ideal from a farm standpoint, because you're putting out the glyphosate at about the right time to put out manganese in the Midwest, where we have a lot of manganese deficiency, a lot of copper deficiency and whatnot. But there, the label says no tank mix is permitted. And that's because it can chelate in the tank, it can chelate in the plant, or it can chelate in the soil. But it does that only as long as there's material, cations, calcium and magnesium and copper, zinc, iron, and all of those materials that it chelates with that are available to tie it up so that it can be there as a chelated mineral, just immobile in the soil, or it can also be captured between the clay lattice structure so that it's detoxified but not degraded. You'll find that when you add high levels of phosphate fertilizer, that the phosphate, glyphosate being a phosphite, but the phosphate in the fertilizer will desorb the glyphosate, remove it from the clay particles, or break the chelation, and it becomes an herbicide again for root uptake by other plants that may not be genetically engineered to tolerate it. So you'll see wheat and barley and peas and lentils and those crops that can actually be severely damaged when that desorption occurs.
So I had this discussion with a chemist one time, and being a non-plant pathologist and a non-organic chemist, I made, I guess, an elementary question, and I said, so if that's the case, what you just described, and I add a phosphate fertilizer, and it desorbs, the glide desorbs and becomes active again as a herbicide as it was intended, wouldn't that mean that glyphosate has a residual activity in the soil? You hear a lot of people say, well, if you're going to plant within 30 days or 2 weeks or whatever, you cannot use this particular chemical, 2,4-D or et cetera. But glyphosate, you can actually, bam, spray, plant same day or whatever you want. Is there a distinction there where you would say, no, that's not a residual, but to me it really is? And is there a time period where that phosphate fertilizer, in other words, if it's added the next day or the next week or the next month?
Well, that will depend. That will depend on the soil type primarily. Most of our soils don't have the organisms present that are able to degrade glyphosate. They may be able to just remove one carbon, decarboxylate one carbon off of it, and you end up with AMPA as a degradation product that then accumulates. It's actually 1.5 times more toxic than the glyphosate, according to the FAO. But it's just there. It's detoxifying through chelation primarily, not by degradation. An example of that would be the studies by Wisconsin scientists here a year or two ago, showing that eutrophication in Lake Erie is from phosphate input from the watershed, but they said that they were getting 1/3 of a pound of phosphorus per acre per year going into Lake Erie as glyphosate, not as phosphate, but as glyphosate. Well, what it tells you then is that the filter strips around the lake that have been capturing this 30 years or 25 years of glyphosate and that's been sprayed both in the forest areas as well as on the farmland has already saturated the chelation ability of the soil in those filter strips, supposedly to keep it from moving into the lake. The consequence of that is that your blue-green algae and some of those are resistant or tolerant to glyphosate, so that you kill out all of the competition, and then you get the eutrophication from the enriched soil or enriched water system then for those tolerant ones that continue to grow and take over in the absence of competition. So that the chelation can be broken, or if the saturation ability from a chelation standpoint is exceeded, then you're going to have this highly water-soluble systemic chemical we call glyphosate move right into the water, as we're seeing in Lake Erie, as reported by the University of Wisconsin scientists.
Okay, and I mentioned to you before the call that I had asked some clients if they had any questions, and these are just clients who I maybe recently were in my text group or my text whatever chain, or we were talking anyway. I told them I was having this podcast. Many of them brought up the degradation? How long does it take? And you mentioned a distinction there between detoxified versus degraded. Can you talk a little bit about accumulation and the slow or reported slow degradation of glyphosate? And in that, where does it accumulate? Does it? Some of my clients actually asked, hey, if I quit spraying a year ago or 5 years ago, is it safe to assume that glyphosate's no longer in my deer in an assumed canned scenario? Obviously, if there's drift or if they move on and off the property, which they do, but in a obviously a non-reality perfect world, how long does it take to remove or degrade itself from our tissues, and where is it? Soil, plants, water?
I think from Farnhurst research in Canada and several others that you can, it'll depend on two factors primarily. One is soil type. The higher the clay content, the longer the residual activity. We have reports of half-life of glyphosate in a silty clay loam or clay loam of about 22 years. So you're talking about a generation or two if you want to get rid of all of it. If in a sandy soil, it's less persistent, not as much material to chelate with, cations and that. The second factor is pH. The lower the pH, the higher the longer the residual activity. And so organic matter, composting, all of those things have very little effect on degradation of glyphosate. For many other pesticides, if you add a little organic material, you'll see the increase in microbial activity and degradation of the pesticide or the chemical. You don't do that with glyphosate because it's a synthetic compound that we just don't have organisms that have adapted or mutated to degrade it. There are organisms that can degrade it, and there are some cocktails that are available now that do a really good job of degrading glyphosate all the way to water and phosphorus and a little bit of nitrogen. But they're not common in soil. So I've seen soil data in Australia and Europe and also in the U.S. where you can account for 25 years of glyphosate application on an accumulated basis. It just continues to accumulate in the soil as long as there's ability to chelate or for it to be trapped in the clay lattice structure.
Okay, so it also, I heard you mention that it accumulates in the meristematic plant tissues. So the roots, the shoot tips, obviously these are things that the shoot tips where deer browse, reproductive structures. So like the stamen and the pistil and flowers, and I'm assuming grain as well, since that's a reproductive structure. And those of you who plant grain products for deer know that could be a problem. And then I've also seen reference to the legume nodules,
Correct.
where it actually accumulates in legume nodules. So I guess then the question is I've seen reference to the fact that it is then released into the soil rhizosphere, which is that area immediately around the roots, through root exudation. And then obviously mineralization of plant residue would release it as well. So this whole concept of this accumulated glyphosate exuding from the roots, in other words, roots exude many things, sugars, etc., where they leak. They literally leak them and attract microbes, feed microbes, and there's a whole lot that goes on there. But I think that kind of blew my mind when I thought about it exuding, glyphosate exuding from the roots.
At about 20%, 15 to 20% is actually released through the roots, so that when you look at the soil, And you say, well, where's my glyphosate? It's not just in that surface quarter of an inch or so that the early research showed how quickly it could be detoxified or chelated with the calcium and magnesium and other minerals, but it actually is going to be released anywhere in the soil. So if you look at alfalfa in the loose soils of the Pacific Northwest, Roundup Ready alfalfa root system will go 15 to 18 feet into the soil, where your biological activity, if you want to have any kind of degradation, is going to be primarily in the upper 6 inches, upper 12 inches of the soil. That's where your high microbial activity is, so that all of that's going out of the root system as root exudates is essentially in a vadose zone where there's no biological activity, and it's just a matter of time before it finally gets down to the groundwater. In Florida, for instance, the U.S. Geological Survey showed as much as 4 ton of glyphosate per square mile in some areas of Florida soils.
Okay, so as far as something else I want to put the rest here, glyphosate and plant pathogen stimulation. So I guess I'll just sort of start it this way. You had mentioned in the past that more than 40 plant diseases are reported to be increased by glyphosate. Fusarium, Phytophthora, etc., pathogens. Can you touch on this?
Well, all of those disease is the abnormal condition for the plant. A healthy plant, fully sufficient for the nutrient, will have a high level of resistance to all of those pathogens. Mm-hmm. When you compromise the resistance, when you compromise the mineral content, you compromise the resistance of the plant. You predispose it. Same thing with us. You get low on your vitamin D3, and you're much more susceptible to a lot of the respiratory diseases. Mm-hmm. And when you start showing a deficiency of manganese or zinc or copper, iron, you'll see that a lot of diseases are increased. In fact, we can identify a lot of mineral deficiencies by just looking and seeing what disease is there. If you have verticillium wilt, you can almost guarantee that they're deficient in manganese. If you have ergot, you either have a late spring frost that kills the anthers, or you're deficient in copper, or you've been using a copper chelating herbicide such as 2,4-D or several others, Tordon and a number of others that are copper chelators. All of your herbicides are chelating minerals. That's the mode of action. We may say, well, it's an ALS inhibitor, a photosynthetic inhibitor, or some other mechanism, but it's an inhibitor because it chelates the cofactor that is the key to turn those enzymes on. It's kind of like having a 200 horsepower engine sitting under the hood of your pickup. That engine doesn't do anything until you turn the key. It's the mineral elements that are the key, the cofactor for those enzymes that do the work. And so if you chelate that element, then that particular pathway is compromised, and you have a good herbicide to shut down the process. And so that's the mechanism that we see with all of the herbicides. It's just that glyphosate and glufosinate and a couple of others are very broad spectrum chelators rather than fairly specific chelators like we see with many or most of the other herbicides.
Whew. Okay. Can you talk a little bit about the project? I believe it was you did, or at least you report on it, when I asked the question of, can you kill a plant with glyphosate in a sterile soil? And the answer is no. But why is that the case, and what did that prove?
Well, the shikimate pathway is a secondary metabolism, not a primary. So that takes a primary metabolism, or shutting down primary metabolism to kill the plant. You can stunt it and have other effects on the plant, but you don't kill it. So that Jessica Sheffers, Bill Johnson, the Purdue weed scientists, were looking at these weeds that are becoming tolerant to glyphosate. They found that in sterile soil, all of them were susceptible, had the same amount of stunting of glyphosate, but they didn't kill them. And the tolerance to glyphosate was based on how quickly they died and the level of glyphosate that it took to chelate the minerals to shut down the shikimate pathway, which then makes them susceptible to the pathogens. So that if you're working in sterile soil, you stunt the plant, but you don't necessarily kill it. If you're working in field soil, normal soil, you always have a lot of organisms, opportunists and whatnot, that when that plant has its hands tied behind its back, so to speak, then they'll come in and pounce on it, and you have a means of doing the damage to the plant. But as long as the plant is healthy, as long as the system isn't compromised, it'll be resistant to those plants. And when you only shut down, or primarily shut down, the shikimate pathway as secondary metabolism, you merely stop the hormone production and make the plant very susceptible to the pathogens. But if the pathogens aren't there, it's just stunted and damaged from a hormone and the overall growth standpoint. Right. That work was done by the initial work in that regard, showing that effect, was by Gary Hall and Rahe and Levesque and others back in 1984. As the mechanism of herbicidal action isn't shutting down the EPSPS system, it's by predisposing the plant to the pathogens. And there are half a dozen really good scientific papers documenting that or demonstrating it, showing that you can't kill a plant with glyphosate in sterile soil because its mode of action is really predisposition to the pathogens then that do the killing for you.
Well, Dr. Don, I wish you were in charge of the COVID-19 pandemic and you could educate the people on what you just described, because this is one of the reasons that I became so frustrated during all that, because America failed. We failed to teach people the true take-home message, which is we should be questioning, why are we farming this way? Why are we growing food this way? Why are we allowing this to happen just so a few bureaucrats and multinational companies can make a boatload of money? So I guess this kind of transitions me to something. I know a lot of my clients are like me. They have ADHD. So here's something exciting for you as you're battling through traffic. And I don't know if this is a two-part question. We'll see how it comes out. But I mentioned in my intro that you've been around with, as far as following the research, essentially since the beginning. And I can only imagine, well, you can Google this and see that you have enemies. People, there's a lot of money out there, and there's a lot of people who don't want others to hear what you have to say. So I guess it's a two-part question. And number one, you've been around the research or the chemical and others from day one. You just mentioned a paper, some incredible science from 1984. I was 6. This isn't new. This isn't something that, one of my clients responded to my text this morning. I said, hey, I'm going to record this podcast. Anything you want to know? And he said, and I quote, well, I'm handling hundreds of the RoundUp cases that are about to settle. And he's in a position, obviously, to be doing that. So it makes me wonder, everybody thinks this is just recent because the commercials have come on TV here in recent years. And again, I'm not taking sides. I think people should do whatever they think is right. But why is so much of this science and all this, since the 70s and 80s and up until now hidden, or it doesn't get the airtime? I guess that's my first question. And is that science hard to do? It's hard. Somebody has to fund science. It's expensive. And the second part of that question is, have you ever feared for your life? I know you've told me some stories, and you don't have to tell what you don't want recorded because we are recording. But have you had issues with people? This is an emotional issue. I told you, I think, one of my clients said, oh boy, good luck. I can't wait to listen. It was just like, well, there was an emotional pull there, right? Oh boy, we're going to talk about glyphosate and its effects on plant health, human health, deer health, etc. So can you kind of address some of that exciting content for some of those who are...
Well, can I go back to the first part of the question, or the introduction to the question on these diseases? We have several new diseases. Sudden death syndrome in soybeans didn't exist before GMO soybeans. You don't think of that because it's common now. It's almost a universal disease. Can cost us up to $1 billion a year, but it didn't exist before glyphosate. Just a few years ago, 2 years ago, actually, I believe, X.B. Yang at Iowa State University reported on his research where if you use a magnesium and manganese seed treatment, you cure sudden death syndrome. All the symptoms of sudden death syndrome are magnesium and manganese deficiency. And yet, here we take a tremendous loss. We have Gauss's wilt in our corn, sweet corn now because of contamination from dent corn. But it's a seed-borne disease. So anywhere the seed goes, the disease goes. But before GMOs, you didn't see that. And that's because resistance to Gauss's wilt, which we've had, didn't move for 30 years from a few counties in eastern Nebraska and southern Iowa, or western Iowa, because we had good genetic resistance. If you have good genetic resistance to Gauss's wilt, it's difficult to get good expression of the genetic tolerance to glyphosate. And so the companies said, well, this disease is of little significance because it never goes anywhere. So they went back to the B14, A632, and some of those that were quite susceptible to the Gauss's wilt, and used those in the crosses. And a consequence now is that we're taking tremendous losses in our maize production from Gauss's wilt. That wasn't an economic problem for us at all before the dollars became prominent in the seed industry. And you'll see a lot of those situations that just continue. As you point out those differences and they start to have an impact, then you have industries or individuals that have picked up on the religion of certain of our new technology rather than just the science. And they feel obligated, apparently, to try and shoot the messenger. If you can't approach it from the scientific standpoint, then you attack the the messenger. So I've had a number of situations in my career as a scientist or a public servant where people have advertised for someone to take me out, and on this issue, that on the GMO issue, and that was the case for several months. An individual was advertising on the internet for somebody to take me out. I understand from my daughter that they even put up a Google map showing people how to get to me. But, in my career, I've been shot at and stabbed and beat to a pulp and a few other things. In my 87-year lifetime, I should have done something to put in my resume, but I don't worry about that. I've tried to be honest in my research, my reporting, and you just go on and do what you know you need to do, and to try and be of service and of help. So I'm past the point of getting a panic situation from any of those things. The truth finally wins out.
Mm-hmm. Yeah, and they certainly wouldn't go to that extent if there wasn't something there that threatened their livelihood or their career. So we'll move on. I know that's not something we want to talk about too much, but just to kind of put emphasis on this topic, that it's a big deal. And I kind of wanted to get this out there while it was still possible. And I have so much stuff here. I think, man, it makes me wonder who's going to continue a lot of this stuff for they don't seem to be, I guess the EPA and any other governance agencies don't seem to be listening to this part, or maybe they're just ignoring it. But I know back in 2013, I remember reading a paper, I think it might have been Science, I don't know where I was reading it, but they were increasing. So they have these maximum residue allowances, right? And I think I might be even heard you and some others touch on this. We can't have any more than 25 parts per million, for instance. I have a note card here. I wrote some of them down. Something has always kind of perplexed me in that, say sugar beets. Everybody, I remember when sugar beets, Roundup Ready, became popular. Every client I had, well, not every, but a lot of people and clients and calls, do you have Roundup Ready sugar beets? And I remember thinking, oh boy, this needs to slow down. But 25 parts per million in the dried pulp is allowed. In the roots, 10 parts per million. In the beets, the tops, 10 parts per million. Canola seed, 20 parts per million. Sweet corn, 3.5 parts per million. Cereal grain, 30 parts per million. Oil seeds, except canola, 40 parts per million. Peppermint, 200 parts per million. Quinoa, 5. Shellfish, 3. Soybeans, 20. Sweet potatoes, 3. And I look at this and I think, let's pick quinoa. What makes 5 parts per million so significant in quinoa, but yet when we jump over to oil seeds, with the exception of canola, which is a Roundup Ready product, 40 parts per million. So why this? I guess it's a two-part question again. Why do they keep moving the goalpost, A, and B, maybe put this parts per million into context for us? That 25 parts per million in sugar beet dried pulp means nothing to most of us.
Well, that's a primary feed for dairy cattle, for instance. beet pulp, and that can go into the milk as well as into the meat of the animal. But you'll find that those levels, as EPA states in the footnotes of the CFR, where they announced the raising of them, they said that the companies came to them and said, hey, these are levels that we're finding in the products that we're trying to sell, and under the maximum level that had been previously established for tolerance, we're not selling a legal product, or we're selling a product that will exceed the legal limit. Therefore, we need to raise the limit, and so in order to have safe food. And so in their footnote, they state that the EPA and FDA have done no independent research to justify these levels. They've relied solely on the information provided by the companies that these levels are safe.
Comforting.
So
in the research that you know of, either that you've read or that you've done, where do numbers like this sit in that continuum? 25 parts per million, or peppermint, 200 parts per million. Can you kind of compare? What are we looking at there to scale?
Well, the scale you're looking at is strictly politics and dollars. Nothing in relationship to health. If you looked at glyphosate as an endocrine hormone disruptor, which you had mentioned earlier on, an interest for you, that you would have to get down to the parts per trillion, or parts per billion at least, tenths of parts per billion, to have a product that wasn't an endocrine hormone disruptor. So those levels are thousands of times above where the clinical studies and medical studies have documented harm and health concerns from a population standpoint, especially for a material that is essentially universal in exposure, and from baby food all the way up to old age. So that you have a bioaccumulant, especially an accumulant that where it accumulates in vital organs, including the brain and the heart and kidneys and liver and pancreas. You have a known carcinogen. There are 32 human diseases that it's a predisposing agent for, if not the agent. The cancer studies, or the cancer lawsuits for non-Hodgkin's lymphoma type cancers, that's only one of 21 cancers that are predisposed by glyphosate. So that you're following the politics and the dollars, certainly not the safety and the health aspects that are involved with this particular chemical.
Yeah. Okay. Well, before I move on, in case those are interested, as livestock feed, they actually elevate. So grass as a forage fodder and hay is 300 parts per million. You can now compare that to the scale that Dr. Huber just mentioned, glyphosate as an endocrine hormone disruptor in the parts per billion. That's now we're 300 parts per million. Cereal grains, 100 parts per million. Soybeans as a forage, 100 parts per million. Soybeans as a hay, 200. Cattle and meat byproducts, or cattle as meat byproducts, 5 parts per million. That, I don't know, maybe I'm misreading that or having a moment, but I thought we learned that lesson during the CJD mad cow disease, not to feedback. But again, maybe I'm misreading that. So I guess before I get on to I warned everyone this would be long, and I still think that's acceptable. You can listen to it in 2 or 3 parts, but there's a reason that in sports, or let's take football, the opponent calls a timeout when the other team is running down the field and seems to be striking on everything and gaining ground. You call a timeout to blow momentum. I don't believe in calling a timeout to blow momentum. So before we get to the Q&A, a lot of questions that clients have, I want to ask you this. I can almost assure you, knowing many of my clients, they're sitting there saying, okay, so what the hell am I supposed to do? Don's been around this a long time. He clearly knows his stuff. I believe him. I'm not even going to argue. That's fine. But what am I supposed to do? Glyphosate, as you know, has made the modern agriculture, especially with genetically engineered crops, RoundUp Ready technology, it's made it so much easier. They claim, I say they, a lot of the conventional farmers, as one of my local farmers has told me for the 16 years I've lived here, we want him to feed the world. I don't want him to feed the world. I don't want to eat his crap, to be honest with you. But I guess what's the take home? And in reality, if you were managing crops for wildlife, as we are, food plots, agriculture, corn, soybeans, down to forages, cover crops, are you saying that you personally, if you and I owned a hunting property together in partnership, you would not spray Roundup? And if you're not, you pull that from your management or as they say, from your toolbox. What are you doing in lieu of it?
What did we do before glyphosate?
Nobody knows, Don. Nobody knows.
Pretty good weed control. Not always the best. You could, or in the early days, you could always tell a farmer that was using glyphosate because there weren't any weeds. It's a very effective herbicide. Became very cheap, but at an extreme cost. If we look at the health costs that are involved and the soil cost, this is a very powerful antibiotic. It's not just a mineral chelator, but it's an antibiotic. Again, that chelation is part of what gives you its antibiotic activity too. But you change the soil biology. Very toxic to the organisms that reduce oxidized iron and manganese that are not available for the plant to take up. So it kills those organisms so that we have a much greater deficiency now in our diets to a lot of the essential minerals. The plant kind of struggles along and doesn't show a lot of visible symptoms, but there are alternatives. We haven't always had it. This is new technology. It's in my generation, in my late generation, actually, that we've had some of these technologies. I think the information that's gained is very valuable, but when you essentially saturate the whole environment with just one product that has such tremendous health impact, you're really doing a tremendous damage. Agriculture is the infrastructure of society. We have a responsibility to produce an abundance of healthy, nutrient-dense food. If you're going to farm, that's part of the responsibility that goes with it. It's not just yield. And so what are the alternatives? Well, it's not just organic. Organic would be at the end of the spectrum. Perhaps a regenerative, even better, because some of the restrictions on organic are actually counterproductive. I think they were initially put in to make sure that you weren't as competitive with conventional. But either way, there are ways to control weeds, and no-till has become a religion. Has its place, a very valuable tool from an erosion standpoint, but you still have to realize that you need some movement, and you're getting some oxygen into the soil, and we get oxygen in the soil when we get water percolation. It's that movement of the water that takes the oxygen down into the root zone. Well, if you have glyphosate, it's toxic to the microorganisms that are responsible for soil aggregation. It's that aggregation that gives you the porosity so that the water can move. Dan Olson's research in Ohio showed that in 5 or 6 years, you went from soils that could infiltrate 8 inches of water in a particular period of time down to less than half an inch, because the aggregant organisms were sensitive to glyphosate. So that then you start seeing the increased contamination as we see in Lake Erie. But tillage is a very powerful tool. We've got a lot of tools that we can use in agriculture for weed control, for nutrient benefit, and those things. And we have some new tools that being developed to get rid of glyphosate from the soil. In the past, we've had to pretty much say, well, we'll just have to outlive it. Well, if you're talking 22 years half-life or even 10 years half-life, it doesn't tell you how long it's going to take for the other half to degrade.
That's all good stuff. And the more you talk, the more questions I have. So I'm guarding against that. But I guess, one of the things that Dr. Rick Haney and I talk about a lot, and clients ask me often, would you from a weed standpoint, we can use the roller crimper to effectively crimp terminate a certain number of plants, but if you had to decide, and I think I know the answer, but which would you toss first, the plow, or, as you mentioned, tillage, or chemicals as a weed control mechanism? And I think I know what you're going to say, but you mentioned the plow as a tool. So what would you say to those who are big no-tillers and say, well, yeah, but the plow is destructive on mycorrhizae, it's destructive on soil structure, it's destructive, walks you backwards? I guess Edward Faulkner, what would you say to that?
On all three of those factors, that's not always true. And it depends on how long you do it, how you do it. So that I've seen situations where a little bit of tillage would have doubled their yield and the quality of their product because their soils were in such bad shape. You get stratification of your nutrients. You have a 10-fold increase in nitrogen loss from denitrification in no-till compared to conventional tillage. So it depends on what your abuse factor is. Using the tool properly can be a positive. It also depends on the crop that you're growing. And you can have a climax ecosystem type situation for weed control with allelopathy. And Charles Sy, a biochemical geneticist that I had the privilege of working with for a number of years at Purdue, had gone through the germplasm in the University of Missouri and other sources, looking for nutrient uptake efficiency, for one thing, and then looking for allelopathic production for weed control. And he found materials that just growing the plant, that it was its own weed control. Mm-hmm. through the allelopathic factor. There's tremendous amount that could be done in that area. A little bit of tillage helps from a nutrient standpoint. A lot of our nutrient systems are dependent on aerobic activity as well as the anaerobic, iron and manganese. We need anaerobic sites in the soil, but we don't need the entire soil. And if you understand the biology of the soil, you see that it's really a heterogeneous, cosmopolitan type of an environment. If you get into a climax or a no-till situation, you tend to minimize some of the other biological activities that could be a benefit. Now, we see no-till corn monocrop for years. Our corn also has a microflora that compensates for some of those effects that soybeans doesn't have. When you go to a genetically engineered maize or corn, you see that it's much more compromised in some of those beneficial organisms than you see with conventional. And so it's a system that we're managing when we're farming. We're not just looking at one aspect or having a religious dogma that you're out of line if you're using some of the other tools, but we use them with an understanding that there are pluses and minuses with most of the things that we do, and we manage them and then so that we can compensate for the nitrogen losses or the nutrient losses or tie-ups that we might have. If you're going to use the Roundup Ready crops, rather than shooting for the middle of that nutrient range for particular nutrients, I always told the growers that they'd be much better off if they'd shoot for the top 75% in that nutrient range rather than the middle ground to compensate for the effect of the herbicide.
All right. So you're agreeing that there's a use for tillage. Are you also agreeing that there's a time and a place to pull out that tool called glyphosate?
No question. And glyphosate, because of its health aspects, should have never been registered. It violates 3 of the 6 criteria for not permitting registration. When you look at the health impact of it, probably should have never been registered as a pesticide to start with.
You know those really hard weeds to kill in your landscaping and on your walkway? Do you spray those?
They're becoming even harder because they're becoming resistant to glyphosate.
Okay, we spent a lot of time on the chelation. I just wanted to make sure, and you don't have to comment on this, Don, but we didn't spend enough time, I don't think, talking about it as an antibiotic. We did talk about it as a very broad spectrum antibiotic, and I always found it interesting when I went through my case of chronic Lyme or whatever it may be, inflammation of the joints, trouble sleeping, night sweats, blah, 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 that everybody, including my PCP, my doc, who basically has now moved on. I think I forced him to move on because he didn't have time to read research. But they essentially avoid prescribing antibiotics to patients, correct? If in other words, I've walked in there during my busiest time and said, listen, I've got something going on. Just give me a script for an antibiotic so I can kill this and get back to work. Oh, no. We need to do these tests and make sure we fear antibiotic resistance. But yet here we are dumping massive amounts, and you have all the statistics, of glyphosate, a very broad spectrum antibiotic that's good at having adverse effects on beneficial gut organisms by, as we said, reducing the number of beneficial bacteria, but then also increasing the number of pathogenic bacteria in the gut and the soil for that matter. So, glyphosate's toxic to beneficial organisms in the soil. That was one of the big questions that some of my clients had. We've already answered that one. But these microorganisms in the soil are responsible. I want to make this point. They are responsible for making these nutrients available to the plant for uptake. And we mentioned the nitrogen-fixing microbes, mycorrhizae, earthworms, and of course, biological control organisms. So again, Don, you don't have to mention anything on that. I just wanted to make sure I cut through that. Do you mind if I ask you a couple of questions for?
Well, I might just add one or two things.
Absolutely.
2 weeks after that, glyphosate goes on a sugarcane plant, which is a perennial plant for 8 or 10 crops, or used to be. It's 2 to 3 crops now. But 2 weeks after that, glyphosate goes on the foliage as a desiccant. The mycorrhizae have disappeared. It's been toxic to them. The other thing that relative to antibiotic resistance is that glyphosate predisposes to all other antibiotic tolerance or activity, so that if you're in a high glyphosate environment, your other antibiotics aren't going to be nearly as effective as they would be without it. And other organisms will develop resistance. If they develop resistance to glyphosate or tolerance of it, they will be also resistant to most of the antibiotics. So we have an increasing frequency of the MRSA organisms. That's a biological effect, antibiotic interaction effect. And that's why your raw honey is still active against as a topical at least, against your MRSA organisms, your Pseudomonas aeruginosa, and those organisms that are resistant to our other antibiotics are still susceptible to some of the antibiotics and some of our natural products. But glyphosate will induce resistance to our other antibiotics. We don't see that with other antibiotic use that would be specific, but with glyphosate, it's across the board.
That's interesting. I never really heard that before. All right, I want to ask this question. So a lot of my clients are also interested in their personal health, and we, over bourbon and steak and burgers and pulled pork and the best grits in North Carolina, oftentimes have this conversation about our own personal fitness and health. And many of them have asked this morning and last night when I sent a text out, something closely related to this. If I want to avoid eating certain foods that have high, it's funny, supposed to be talking about deer, but they went right to their health. Foods that have higher concentrations of RoundUp or glyphosate in them, which foods should I avoid? And sort of related to that question as far as, are there certain foods I should avoid? I hopefully don't say my oats that I had for breakfast this morning, or my grits. Is organic really void of glyphosate and other synthetics? And if it has trace amounts, perhaps it's still better than non-organic. So I guess that's kind of the question of if I were to avoid eating certain foods, what would they be?
Again, organic would be the easiest to identify because we don't have labeling for glyphosate. There is a glyphosate label for glyphosate-free food. Henry Rowland's program has introduced that, but it's a little bit expensive to analyze for glyphosate, $300 or so a sample. Mm-hmm. That's the cost of one visit to the doctor, though, and not all the follow-up that's required. But
this is true.
You have exposure, but glyphosate or organic is probably the single most important aspect. Ted Duitmeyer says is 3 to 5 days after he changes a herd from normal to an organic or a non-glyphosate contaminated feed, death losses stop. And so you'll see that impact fairly quickly. May not see it as much, but the impact is there. And you look at Dr. Monica Kruger's research at Leipzig University and veterinary pathologist shows that 2 to 3 weeks after removal from the glyphosate exposure that the health improves, chronic botulism stops. As soon as you pick up, they go back to the glyphosate levels, and these are just levels residual in the European food, which is much lower than ours. You'll see that the health issues start coming back. And in our situation, we have a lot of residual glyphosate in our tissues and organs, so it may not be quite as fast. The other thing is to know the source of your food. Buy local. Talk to your farmer and see what he uses, how he uses it. Using it as a burn down or just for fence row maintenance or that type of thing, or is he dumping it on the food with his GMO crops so that it's as a systemic material it's going to be there? Compensate for some of those effects. See what your nutrient levels are. 70% of the population is deficient in manganese. About 90% probably for vitamin A, and if you're north of the 38th parallel, probably D3 would be a wise thing to have as almost a chronic daily intake. So you can compensate for some of the effects through a good nutritious program. Your best source of those minerals and vitamins is your food. But if it's not in the food, then you need to look at the supplementing that with some other sources. Again, it becomes a question of how do I know if I should use the magnesium oxide or the magnesium glycinate or something else? Which one's better? And you'll see that there are a lot of different absorption factors that come into play. Bonnie Kaplan has a lot of that information in her publications relative to mental health, and showing how different sources, different chelators, and that have a dramatic effect on whether it's absorbed. Are you increasing the mineral content of your septic system, or are you really getting it into the muscles and into the tissues, into the liver and kidney and whatnot, where you really need them?
Yeah. Did I hear you say once that garbanzo beans tend to be higher in glyphosate?
Garbanzo beans were the highest, and of course we pushed that because they're high mineral accumulating, and but had over 5,000 parts per million reported in some of the garbanzo beans because they are desiccated. Garbanzo beans, kind of like lima beans, the pod matures, but the plant keeps growing and keep trying to pump just as much nutrient in there as it can. But it's also, when you desiccate, the only place that systemic chemical can go is into the seed. That's the only, or the primary sink that's left. Your root apex and all of those have pretty much stopped. But with the garbanzo bean, you keep a green plant, and of course it helps to have that plant dry down for combining rather than having to run all the vegetation through when you're trying to crack the pod and get the bean out. And lima bean also. So many of them are desiccated for that purpose, and consequently you have a very high concentration. The other thing, the minerals concentrate in the seed coat and the bran, so that white bread has a lower concentration of glyphosate than whole wheat bread, but it also doesn't have the minerals. So that you lose from a nutrient standpoint anyway when you have to look at glyphosate.
Now, I guess I should have brought this conversation back to deer, turkeys, quail, ducks, wildlife more than I did. But again, I want everyone to know that anything we talk about as far as, health related effects of gly can obviously go to the deer. That client of mine who mentioned that he's currently handling hundreds of RoundUp cases that are about to settle, my response to him was, that's interesting. Who is the legal counsel for white-tailed deer? And when will those cases start to come against people? Because it really pisses me off that an animal that I love is so negatively affected. So this particular client is like me. I remember who this question came from. Another kind of and we've covered some of this, but I want to address this specifically. He says, how long does RoundUp or glyphosate, and I put or AMPA in parentheses, stay in deer? And I think we're talking about this residual and degradation and detoxification. And obviously it's hard to answer scientifically, but he says if you go from Roundup ready crops to no spraying of glyphosate at all, is it out of those deer in one season, 1 year, or never? And then also he says, does the chemical residue, where does the chemical residue in the animal lie? Fat cells, meat? Again, these are his questions. So,
well, it bioaccumulates. Probably 85% or so is eliminated through the kidneys and the feces. Kidneys are a primary source. That's why you get end-stage kidney failure when it chelates with the minerals, because it plugs up the kidneys. When you can add some materials that will move it more through the liver and through the feces, and that'll depend a lot on diet on doing that, but it bioaccumulates in the brain and the heart, liver, and kidney, and all of your muscle tissue, but especially in the brain and the heart, so that you're compromising that copper in your brain tissue that's critical, so that we have situations reported of CJK in areas where they have no family history of Creutzfeldt-Jakob disease anywhere for eight or nine generations, and all of a sudden you'll see in an area that you have a very significant outbreak of that particular disease. Well, again, you look at those and you look at the glyphosate utilization, and I think you would find a very close correlation, as Nancy Swanson did, looking at the CDC data and human diseases. With the glyphosate correlation, it's up to 0.99 Pearson's coefficient. When I was in another position with the Surgeon General's office in the Department of Defense, when we would look at a new disease outbreak somewhere in the world, would look for all the correlating factors, and 0.5 or 0.52 was where we would get excited enough to get a scientific panel. Here we're seeing 0.99, 0.98. for literally 32 or 34 diseases that we've just ignored what appears to be the primary causal factor for it. Non-Hodgkin's lymphoma lawsuits are certainly valid in that aspect, but how about end-stage kidney failure, where you have 25% of your young men that are dying from end-stage kidney failure? As the Canadian Health Authority has stated, that 1/4 of Canadian population already has preliminary end-stage kidney failure. Why aren't we addressing a lot of these relationships? And of course, it comes down to following the dollar.
Mm-hmm. Absolutely. So this one here is actually really interesting. This question says, or asks, when you apply glyphosate one time in, say, 4 years to an incredibly healthy soil. So in other words, let's say you have somebody like me who believes in regenerative agriculture, minimizing disturbance, promoting biological activity. We love microbes, etc. There's healthy soil function, full of diverse microbes. His question is, how detrimental is that one application to the soil life compared to soils that have 2 to 4 applications per year as are typically applied? I guess sort of the question is, it's almost like a cheat day, right? When, for a guy or a gal who's in great shape, if they go out one night and they drink a bunch and then they, eat pizza and have a big piece of chocolate cake, that's okay, right? Just that one application every now and then?
Well, the soil has a tremendous ability to change, but it has to have the organisms there to do it. And with glyphosate, most soils, we don't have them. It hasn't been used for 1 million years or 1,000 years. Like with petroleum degradation, those organisms have been exposed to it, to a lot of those products for years, and adapted so that there's fairly rapid degradation in almost all of our soils for petroleum products. We don't see that with the glyphosate. And when you look at the clay content being a critical factor for longevity and pH, the lower the pH, the longer the activity, and then you see the biological aspect of that. Those organisms don't get into the clay lattice structure as easily as in a sand situation. But there are organisms that will do it. And when you ask, well, once versus 3 to 4, it's kind of like saying, well, if you're playing Russian roulette, it depends on how many blanks you have in there. But your soil type's going to be a factor, so that if it's going to bind it and not degrade it, but where it's not an active compound, but essentially just a part of the inert soil structure, may not be a problem at all. But if you desorb or if you saturate that system, you're going to have greater exposure to it and a release, so that in the future it's an unknown. Right now, that first year, you're going to see a compromise of your nutrition from a biological as well as a chelation standpoint. The antibiotic activity can last longer than the chelation in many respects, because when you shift the biology, there isn't a void in nature biologically, so that you shift so that you have other organisms that fill that void that then slow down or change the speed of recovery, because it's who's at the top of the hill that kind of controls the system for a lot of these microbial interactions. And Certainly, the quicker that you stop adding to the problem, the quicker the recovery.
Okay, so can you get behind a guy and support him or her or a gal for any reason to those? I often hear people say, I use it responsibly. I follow the label, one application or X number of quarts per year. You're saying you can't get behind him at all for that one application?
No, that label is, our label says it's safe to use glyphosate anytime before seed emergence. So our onion producers will go out and they'll plant in the morning and they'll spray glyphosate in the afternoon. They don't dare wait 3 or 4 days for fear of germination, and then they know that they lose their crop. But even with that amount of exposure, you can have an 80% reduction in your final yield following that program, because it takes a while for it to become immobilized in these soils. The Israeli label for glyphosate, I don't know what it says now, but 10 years ago it said it's not safe to plant into glyphosate-treated soil for up to 3 weeks without taking a yield reduction. Pokeram held and Horst Marschner and the group in Germany showed that a minimum of 2 weeks after applying the glyphosate was required before you got the same stand of wheat or barley from one application that you had without any wheat or barley, or waiting until it was fully chelated and immobilized for that 2-week period. So our labels sometimes reflect more of the company aspect than the science.
Good stuff. All right, this one kind of relates, I guess. He starts off and says, "I'm not anti-gly if used properly," and that I kind of made that my own question. So is that even a possible thing to use it properly? You're saying no, I think, if I'm hearing you right. But he continues on. Go ahead.
You have to know that there are consequences to using it, and if you can compensate for that, or if it's a situation where that isn't going to interfere, I don't know where those would be, but I'm not anti-chemical. I get a little irritated when I look at an organic grower and can see that there's a micronutrient that would make a tremendous difference, both quality-wise and yield-wise, disease-wise, but he can't use anything that's economically available to him because of the restrictions on from the organic standpoint. I think sometimes we cut off our nose to spite our face in these areas, and you look at the situation, and a lot of the materials we use for chemotherapy of different diseases are certainly very toxic, but they're used hopefully very judiciously, and only until that situation can be corrected, and then you do the remediation aspects. And that's one thing with glyphosate, that there are 4 or 5 different groups that working on active remediation, and some of those are really fairly remarkable as far as that residual, getting rid of that residual glyphosate. So we're having some, things open up in those areas that weren't available 5 or 6 years ago or 10 years ago. 20 years ago, my approach was, let's get out with some lime or some gypsum and let's tie the darn stuff up. Let's make sure it's all chelated. Well, that just kicks the can down the road. I think we have the economic possibility now, a very realistic possibility to degrade and clean up the landfill that we've created, rather than just having to kick it down the road a little ways.
This gentleman asks, shortly after spraying Roundup or glyphosate, if an animal consumes the plant, does that affect the animal and possibly the person who will eat the meat? Again, direct from a client, and I know we touched on sort of a lot of that, but how would you answer that question if that were pulled out of context and just asked?
Well, there's really excellent science. And one of those chapters that I sent you from Ted Dupemeyer, where he's done the glyphosate analyses and everything on the feed and the animal. You see that it's a bioaccumulant, so that it accumulates in the body. And with glyphosate, it's not only in the organs, but also in the muscle tissue and bone tissue. So that, yes, it'll be there. Its concentration will be dependent on the concentration in the feed, but the organs are going to be higher concentration than the muscle tissue. But in fact, I have a friend that was inspection of slaughter houses, and said about 80% of the livers can't be used in commercial slaughterhouses because of the friability and other modeling, other damage that we see associated with glyphosate. And as Ted has done, he's actually shows those glyphosate levels in the different tissues. And so if you're consuming that, that's what you're going to consume. Now, a lot of that glyphosate that's consumed by the animal is also excreted, but it's a systemic bioaccumulating type of a compound. Find a lot of our dairies now that only have 2 or 3 gestations on their cattle before they have to cull them out. And hamburger prices are high enough that they can still make it economically to cull the cattle out. But if they go more than 2 or 3 gestations, chronic botulism and other health factors, mastitis and whatnot, become to a point where they start losing the animals, and then they can't be salvaged for meat purposes.
Fair enough. I'm gonna clip over a couple more of these. This is now the official longest podcast we've ever done, and justifiably so. But this client's sort of a man after my own heart. He says, "What all insects is it killing that people are not aware of? Honeybees and their role." We didn't touch much on this, and I think you probably will here. I had honeybees that did very, very well till my beekeeper unfortunately passed away rather quickly. And we had a unique story where we were breaking off of our hives to take to others who had complete colony collapse and problems. And then he says, beyond that, if wild turkeys eat those insects or the dew from the plants, so he's obviously worried about the turkeys like I am, after they're sprayed, what are the side effects of that, and is it fatal?
Yes, it's fatal on bees. A good study of, I believe, it's not Falk's study, it's Amos's study, where he showed that the antibiotic activity of the glyphosate at very low levels in the nectar destroy the lactobacillus and bifidobacteria that the honeybee has to have in order to digest the proteins, the nectar, and those materials. So that he showed that the tissue is actually dying from starvation in the honeybee because it can't digest the the food. So it's very damaging from that standpoint, but also from a resistance to mites and moth and your other disease aspects for honeybees. So they're not excluded in any regard. They get caught both by the low mineral content and tie up, as well as by the antibiotic activity.
Yeah, as are many of the organisms impacted, whether it's the microorganisms or us or white-tailed deer. It seems like we get hit from multiple avenues, whether it's nutritional decline, antibiotic, etc. This client, we hit most of his other questions, but he does ask this, and I've thought about this back when I used chemicals. He said, I try to use gloves, but always manage to get some on my skin. Are there any studies of Roundup going through the skin, and how does that differ from, I guess he's saying from, differ from going through plants, etc.?
Well, it's a systemic chemical, so it goes through the skin and then gets into the bloodstream and circulates. It was advertised as being so safe, and that with very minimal personal protective equipment required. And where they advertised it as being non-toxic, totally non-toxic to mammals, because of the lack of the shikimate pathway. But as you mentioned, it's highly toxic to most of your beneficial organisms in your GI tract. That people, including myself, became very lax in protecting ourselves from that skin absorption. But it is skin absorbed in the rabbit studies. It moves through, and in other studies, there is somewhat of a barrier there, but it's not a protectant, and well worth putting on the gloves and the goggles and making sure that you get your clothes changed and whatnot when you get spray on it, drift on it in those areas.
Mm-hmm. Well, Dr. Huber, I absolutely appreciate all of your time. I'm going to start to slowly wrap this up. I know everyone who started listening is still listening, because I think it's a topic that demanded a 2-hour plus podcast. If people like you are not educating the public and people like me, then, as you mentioned, in nature, there are no voids. So that means someone else moves in to do it. And I'm sitting here with 2 documents, ironically. Didn't plan that segue right there. But I'm holding 2 documents. I always like to do a internet search, white-tailed deer and glyphosate and Roundup, and just see what comes up. And 2 of the first hits. One is by a fellow outdoor writer of mine, so I won't bring up his name, but someone had asked him, he's an outdoor writer, a damn good hunter, but certainly not an expert on glyphosate, and should have stayed in his lane or done some more research on this. But this misinformation is not, it should not be tolerated, period. And the question is, dear Bill, I want to put in a food plot this year on a 1/4 acre. I'd like to spray it with glyphosate. I was just wondering, could this potentially harm the deer if they were to eat the spray? And he has a whole lengthy response. Basically says, in your case, you're spraying the weeds and then planting a food source. The deer are not likely to eat those treated weeds, so go for it. However, in the case of those who spray Roundup or glyphosate directly on their Roundup-ready plants, such as beans and corn, that does create a bigger issue. Fawns of does that eat glyphosate-treated crops are more likely to have birth defects that are consistent with mineral deficiencies than those that don't. This is because glyphosate renders minerals in the plant less available for deer. Not necessarily true, but I see where he's going with it. I think as long as the deer have many options that are not treated with glyphosate, such as brassicas like Big and Beastie or cereal grain blends such as Autumn Quick Plot, the amount they ingest will be very low. So interestingly, the products that sponsor him are products that you should probably go for, like these brassica products, etc. So again, just not intentional, but misinformation. And this is how bullshit gets conveyed from generation to generation by people who step outside of their lane. Another one by, I think this is the NDA or one of those, NDA. Basically the title, Kill Them All, right? This is what glyphosate does, kill them all. They're just educating you on 5 herbicides every deer steward should know. After listening to this today, I'll let you decide if a deer steward should kill them all and use glyphosate. I don't know. At the very least, they probably should have had a footnote educating you about both sides of the story and all the facts that Dr. Don presented to us today. So the last question actually was one of the questions that this gentleman had asked. I saved for my segue in my closing here. I'm going to save that for after I ask Dr. Huber. Do you have anything you feel you should have expressed? Is there anything you know to be true about this whole story, debacle, whatever, that you would like to put on the record, or did we hit it all?
Well, I'll just say that a lot of those weeds that we used to have commingling with our plants served a very important ecological function. They see nutrient cycling, nutrient availability changes from changes. Each plant has its own biology, and we see the advantage of crop rotation, crop cover cropping, and those things that where we can take advantage of those differences. But they weren't there just because they wanted to be there to hassle us a little bit. They were there performing a function or because the environment wasn't there. Jay McCammon has a little booklet out. Acres Press publishes it, but just showing why weeds grow. And there he has 35 or 40 pages of table just showing the various nutrient conditions, and they can be a really valuable tool for us just to identify what our soil needs are for our regular crop. You'll find a lot of weeds grow where there's a copper deficiency or a calcium deficiency or a phosphorus deficiency, and Jay has put those into a table form, and it's really remarkable how close that is, how much information we can get. But what they're doing is they're trying to improve that soil condition. And then that can be a very positive to have a few of those. You don't want them to be a competitor for your crop, but to have a few weeds doesn't mean that you shouldn't sit next to your neighbor in church on it, because those weeds may be having a very positive function and working for you, and we just haven't recognized it in the past.
That's right. I personally I bought that little booklet that Jay produced years ago and read it and enjoyed it, and I've, of course, use it in my day-to-day work. Boy, it's almost like I gave you the script the way you finished that, because the one of 4 questions that this particular client from Louisiana wanted me to ask, I saved his 4th one to sort of segue into my close. And he says, I personally haven't used it on 98% of our place for years, and his plots look amazing. He's been 3 years, I think, now on reload, and we've been pulsing different things and working on really making those plots thrive. But he says, I love this part right here. This tells me that I've done a little bit to help move him along, but he's also just a information hungry and motivated individual. He said, I see weeds differently now, with a wink. we've mentioned weeds a lot, and until you just closed it in a phenomenal manner there, I wanted to say that, hey, listen, a lot of these weeds are great medicinal plants, and they serve a phenomenal purpose in soil health. I received about 7 emails the last time from my last podcast, or the one before that. I mentioned ragweed's my favorite cover crop, and it still is. I love the plant. I love what it does to the soil, or at least what the mycorrhizae tell me, and the soil around the rhizosphere tell me. But I think we spend way too much time trying to kill quote unquote weeds instead of just worrying about the damn soil health and focus on that. I'll close with the story real quick. My e-commerce, of course, selling seed, 100% is word of mouth organic, except for my e-commerce, Drop-Tine The folks who sort of manage and push my e-commerce site, they want me to be more like the Shopifys and the Amazons, and I'm a field biologist, so I can only handle so much of that. But they hammer me because I don't have great pictures. They want professional photography, and I love photography. I totally agree with them. But they say to me, don't you have a perfect picture of what fall reload looks like, or a perfect picture of what summer nourishment looks like? And I say no, because quite honestly, I can't control what my clients do. They always have something else in the field prior to that. None of us are starting, well, very, very few of us are starting with a completely weed-free, nuked, burned down field, because we're on the soil health plan and we follow those principles. So they're wanting pictures of spring reload that looks exactly like the client's going to get. And this has been a struggle as I developed new blends, the reload blends especially, and the nourishment blends, and squatch, because oftentimes we are relying on winter termination. We're relying on crimp termination. We're not getting 100%. Hell, sometimes we're happy with 50% termination of weeds, and we go right into that with the very next crop. And guess what the deer think about that? They absolutely love that. Species that did not show up in their diet before are now starting to show up in their diet because of symbiotic relationships and with other plants and increased soil health. So I'm glad, Don, you said that. You mentioned the weed part. It's something that I'm probably the only deer guy who sends soil samples out from monoculture ragweed plots. Because I love what I learn and see that plant, that's just one of many. Goldenrod is another incredible plant. So with that, thank you so much, Dr. Huber, for spending all this time. I know we had this on the calendar for quite a while. I've been wanting to talk to you for quite a while, even longer. Thank you. And hey, if there's anything else you want to add or say or close with, we're all ears.
Oh, I just thank you for letting me share a little bit of information here, and encourage you to keep up the good work.
Well, thank you very much. We appreciate that. And again, I wanted to reiterate, thank you for your service as a veteran.
Okay. Well, that was a privilege and responsibility of citizenship. And,
yes, sir.
I appreciate this great land that we've been privileged to reside in.
Amen. All right. Well, very good. I'm going to let you go, and I'm going to close this out quite simply because it's been a long podcast. I want to thank everybody for listening. And I say this not every time, but obviously I'm not a huge fan of advertising when I listen to other podcasts. I realize how much time I have, over 17 hours, just in preparing for this particular podcast. It takes a lot of time, and it takes money, but time, more importantly, is money. I don't like listening to minute and a half, 3-minute advertisements, and as a result, I certainly want you to have to do that, and I wouldn't want to obviously have to mention those particular products and services in the podcast. So if you want to help me out and you appreciate that, please go on your app, wherever you listen to your podcast, and leave a review. Please rate the podcast, and just that right there is the biggest reward for me when I get to read the reviews and see what folks think of the podcast. So thank you so much, and that's all we have for today.
Thanks, Jason.
Yes, sir. Have a great one.